Right, example 3 is wording you may not see very often, but it's useful to know what it means. And I've also deliberately used a more obscure notation so we can decode it and work it out. Right, so the question states, prove by perfect induction that the not of A and B is equal to not A or not B. Right, so perfect induction just means use a truth table. Right, so if we look at our expression, how many variables have we got? We have an A, we have a B, we have an A, we have a B. We also notice we have a left-hand side and we have a right-hand side. Okay, let's go ahead and do this. Okay, so to start off with, you have to generate all possible values for A and B. And so to do this, we use our standard pattern, and we know we have 4 rows because 2 times 2, each variable having 2 states, and 2 times 2 is 4, so therefore we have 4 states. So we begin with our normal pattern 0, 1, 0, 1, and we then double the pattern up, double 0, double 1. Alright, only 4 variables, so only 4 states because there are only 2 variables. Okay, so the first thing I need to work out is the value inside the bracket, and the value inside the bracket over here is A and B. Alright, horrific table work here. Right, finally got on top of that. So A and B. Right, so I should know from my my perfect, the ultimate truth table, that the only place I'm going to get an output of a 1 is with both inputs of 1. I can also use Boolean short circuit evaluation to remind myself, if any one of the inputs is 0, I'm going to get 0. So there's the truth table for A and B. What I now need to do to completely evaluate the left hand side is to negate this to work out the not. So if I now put in LHS for left hand side, alright, I just have to negate the A and B column. So here we go. So all 1s become 0s, and all 0s, so all 0s become 1s, and all 1s become 0. Right, so that is the left hand side evaluated. Right, let's have a look at the right hand side. In order to work out the right hand side, I have to use the values of not A, and I have to get the value of not B. I don't in my truth table yet have columns for not A and not B, so that's where I need to begin before I can work out the right hand side. So not A and a column for not B. Right, so the column for not A, whatever A is, just flip it. So the 0s become 1s and the 1s become 0. Right, moving on to B, column B, same principle applies. Wherever B is a 0, not B will be a 1, and vice versa. Alright, so I can double check because you can see the pattern is completely and utterly just the reverse of what I had on the left hand side over here. Right, finally, to work out the right hand side, I have to OR. Because this is a V. I have to OR the column not A with the column not B. Alright, so right hand side. Okay, we start the table. Right hand side, I'm ORing these 2 columns over here, not A with not B. Right, because I'm doing an OR, short circuit evaluation says if I have a 1 in any one of the inputs, I get a 1 out. So looking at those 2, for not A, I'm going to get a 1 out. Looking at not B, I get a 1 out for over there, which leaves the only 2 where I'm going to get a 0 out is where both are 0, which only happens on the final row. So the final thing I now need to do is say, is this in fact proven? Right, just shifting the table up a bit so I've got more space. And what I have to now do is compare the left hand side column with the right hand side column. And I'm checking whether they are equal. And so the result I'm going to write in this column is this true? Is the left hand side equal to the right hand side? So we go through and we match entry by entry. So is 1 equal to a 1? Yes, it is. Is 1 equal to a 1? Yes, it is. Is 1 equal to a 1? Yes, it is. And is 0 equal to 0? Yes, it is. So that is getting a 1 there as well. So there we have it. We've proven by perfect induction, or in other words, fancy words for it, by using a truth table, that the not of A and B is equal to the not A, not B, or together. If I write this in, this is a bit hard to see what's going on here. If I write it in the other notations that we know, things become a bit clearer to see. So this could be written as A and B not is equal to A not plus B not. So if you look at what's happening over here, if I have a negation, alright, I can actually apply that negation throughout the entire bracket to remove the bracket. What happens is I need to negate the variables. So not A, so A becomes not A, B becomes not B, and this is the important thing, which is completely counterintuitive, but it works. We've just proven it works. That the and must become an or. This is actually known as De Morgan's law, and it is a very important law. And basically what it says is that if you not an and, you don't just, to remove the bracket, you need to not only negate the variables, but you need to change the and to an or. That's it. Thank you for watching.